Good morning, everyone. Welcome to a pivotal discussion on FrugalGPT, how to use large language models while reducing cost and improving performance. As we delve into this presentation, we explore the pressing challenge of leveraging the power of large language models in a cost-effective and environmentally sustainable manner. This research introduces FrugalGPT, a novel framework designed to optimize the use of LLM APIs without compromising performance. Prepare to uncover strategic insights that promise significant cost reductions and enhanced efficiency in LLM applications. Let's embark on this enlightening journey together. As we delve into the realm of large language models, or LLMs, we're confronted with significant challenges that hinder their broader adoption. Primarily, the high operational costs and environmental impacts associated with these models pose substantial barriers. These challenges underscore the urgent need for cost-effective strategies across various sectors, prompting us to rethink how we deploy these powerful tools. Turning to the existing landscape, we find that most strategies, such as Model Cascade and FrugalML, have been primarily designed for classification tasks with a fixed set of labels. This leaves a noticeable gap in strategies tailored for generative tasks, which often require handling open-ended outputs. To bridge this gap, we introduce FrugalGPT, a novel framework designed for the budget-conscious utilization of LLMs without compromising performance. FrugalGPT innovatively incorporates strategies such as prompt adaptation, which focuses on crafting effective yet concise prompts, LLM approximation, which aims to replicate the capabilities of more powerful models using less resource-intensive alternatives, and LLM cascade, a method that strategically selects the most cost-effective model to handle each query based on its complexity. This approach not only promises substantial cost savings, but also aims to reduce the environmental footprint of deploying large-scale language models. As we delve into the transformative potential of large language models, or LLMs, it's crucial to recognize their expanding role across diverse sectors such as commerce, science, and finance. These models are not just theoretical constructs, but are actively reshaping how we interact with data and make decisions on a large scale. The figure displayed here encapsulates our innovative approach with FrugalGPT, which marks a significant shift from traditional single LLM usage to a more dynamic, multi-tiered strategy. This strategy includes prompt adaptation, LLM approximation, and an LLM cascade, all designed to reduce costs while enhancing accuracy. Specifically, our results on the headlines dataset demonstrate how these methods can lead to substantial cost savings and improvements in performance, setting a new benchmark for efficient LLM utilization. As we delve into the challenges of leveraging large language models, or LLMs, it's crucial to recognize the significant barriers they present. Firstly, the high operational costs and environmental impacts of running these models are substantial, making widespread adoption challenging, especially for smaller entities. Furthermore, the LLM marketplace is diverse, with a variety of APIs available, each differing in cost and performance. This diversity presents a complex challenge, selecting the most appropriate LLM API for specific tasks without incurring prohibitive costs. Addressing these issues requires a novel approach. We need strategies that allow us to use LLMs both affordably and accurately, ensuring that we do not compromise on performance. This is not just a technical necessity, but also a broader imperative. The high costs associated with these technologies restrict access for small businesses and independent researchers, while the significant energy consumption has broader implications for our social and environmental well-being. As we delve deeper into the realm of large language models, we encounter significant challenges with existing strategies like Model Cascade and FrugalML. These approaches, while effective in certain contexts, fall short in addressing the unique demands of LLMs, particularly in terms of cost efficiency and environmental impact. To bridge this gap, we introduce FrugalGPT, a pioneering framework tailored to optimize the utilization of LLM APIs. This framework is designed to operate within budget constraints without compromising performance, making it a game-changer in the field. FrugalGPT brings to the table key innovations such as prompt adaptation, LLM approximation, and an LLM cascade strategy. These features collectively contribute to substantial cost reductions and enable the adaptive selection of APIs based on the complexity of the queries. This strategic approach not only enhances efficiency, but also aligns with our commitment to sustainable practices in AI. FrugalGPT represents a transformative approach in the utilization of large language model APIs, striking an optimal balance between cost efficiency and performance. This framework is particularly designed for scenarios where budget constraints are as critical as the accuracy of the results. At the heart of FrugalGPT are three core components. First, we have prompt adaptation, which focuses on minimizing the length of prompts. This reduction is crucial, as it directly... Next, we introduce LLM approximation. This involves creating simpler, less resource-intensive models that are capable of emulating the functionalities of more complex and expensive LLMs for specific tasks. This not only ensures affordability, but also maintains a high standard of task-specific performance. Lastly, the LLM cascade component is where the real cost-performance optimization occurs. Here, we strategically use a sequence of multiple LLMs, selecting them based on the complexity of the query and the associated costs. This method allows us to use more economical models where feasible and reserve the more expensive, high-performance models for particularly challenging queries. Together, these strategies form a robust framework that not only reduces financial and environmental costs, but also maintains, and in some cases enhances, the accuracy of responses in large-scale applications. Let's delve into the training and operational mechanics of FrugalGPT, our proposed cost-effective strategy for leveraging large language models. The training process of FrugalGPT involves using a set of labeled examples to fine-tune the cascade strategy. This training is crucial, as it teaches the system when to switch between different LLMs to optimize both cost and accuracy effectively. In practice, the operational details of our LLM cascade are designed to maximize efficiency. Initially, queries are processed by more cost-effective models, such as GPTJ. If the query is more complex, and the response from GPTJ does not meet the required confidence threshold, it is then escalated to a slightly more expensive model, J1L. Only the most complex queries, which cannot be resolved by the first two tiers, are sent to the most expensive model, GPT-4. This tiered approach ensures that we use resources judiciously, escalating to higher-cost models only when absolutely necessary. This strategy not only preserves the quality of responses, but significantly reduces operational costs, making it a sustainable choice for large-scale applications. Let's delve into the technical workings and experimental validation of FrugalGPT, our proposed solution for optimizing the use of large language models within a budget. The core of FrugalGPT is an algorithmic cascade that smartly navigates through a sequence of LLMs based on the complexity of the query at hand. Initially, a query is assessed for its complexity. If it's relatively simple, it's directed to a less expensive model, like GPTJ. The response is then evaluated, and if it doesn't meet the quality threshold, the query is escalated to the next LLM in the cascade. This process continues until we either obtain a satisfactory answer or exhaust all available LLM options. To ensure the robustness of FrugalGPT, we've rigorously tested it across diverse datasets, including headlines, overruling, and COQA, each chosen for their unique challenges and relevance to real-world applications. These experiments are designed not just to test efficacy, but also to demonstrate FrugalGPT's ability to significantly reduce costs while maintaining, or even enhancing, the quality of responses. This approach not only showcases the potential of model cascading in practical applications, but also sets a new benchmark for cost-effective LLM utilization in the industry. Let's delve into a compelling example from the headlines dataset, where FrugalGPT showcases its capability to predict market trends efficiently. By leveraging a sequence of LLMs tailored to the complexity of the query and the budget constraints, FrugalGPT not only predicts a downward trend in gold prices after dismal U.S. GDP data, but does so at a fraction of the cost typically associated with using high-end models like GPT-4 alone. Moving on to the innovations brought forth by FrugalGPT, it's important to highlight how this framework refines the use of large language models. Unlike traditional methods that rely on static deployments of costly models, FrugalGPT introduces a dynamic approach. It assesses the complexity of each query to decide the most cost-effective model to deploy, ensuring both financial and computational efficiency. This adaptability marks a significant advancement over previous systems like model cascades and FrugalML, which were not designed to handle the open-ended outputs of LLMs. Through these improvements, FrugalGPT not only reduces operational costs, but also enhances the accessibility and sustainability of using large language models in real-world applications. Let's delve into the technical results of our FrugalGPT framework, which showcases significant advancements in cost-effectiveness and efficiency. Our detailed analysis reveals that by intelligently triaging queries, FrugalGPT drastically reduces operational costs without compromising on quality. In fact, it maintains or even exceeds the accuracy of the best individual LLM API available. Moving on to our ablation studies, these have provided insightful implications on the system's performance. We explored how varying the cascade length affects both performance and cost. The results indicate that an optimal cascade depth can significantly enhance cost efficiency while maintaining high accuracy levels. Additionally, we evaluated the impact of prompt adaptation. By modifying prompts, we not only achieve savings, but also observe notable changes in performance, highlighting the effectiveness of our approach in adapting to different query complexities. These findings underscore the potential of FrugalGPT to revolutionize the use of LLMs in a cost-sensitive environment, making it a viable solution for a wide range of applications. Ladies and gentlemen, as we conclude our presentation, let's reflect on the significant strides we've made with FrugalGPT. This innovative framework not only addresses the financial constraints of using large language models, but also ensures that performance remains robust. By integrating strategies like prompt adaptation, LLM approximation, and the LLM cascade, we've tailored a solution that significantly cuts costs while maintaining, and in some cases, enhancing accuracy. Our empirical studies, particularly with the headlines dataset, have been telling. FrugalGPT's cascade strategy effectively utilizes less expensive models, such as GPT-J and J1L, before calling upon more costly options like GPT-4, only when absolutely necessary. This approach has led to an impressive 80% reduction in costs and a 1.5% increase in accuracy compared to using GPT-4 alone. These results underscore the potential of FrugalGPT not just as a cost-saving measure, but as a means to enhance decision-making in real-time applications across various sectors. Thank you for your attention, and we look forward to exploring further applications and improvements in this exciting area.